Hi, welcome back to my channel, Senior Informatica. This is your Srinivas. Today topic is derivation trees. Is a part of theory of computation. Why we are going to use the derivation tree? What is the importance of it and their application? Where we are going to using this derivation tree? What are the different names we have for the derivation tree? We will know here. Coming to the derivation tree is also known as Parse tree or syntax tree. It serves as a visual representation of a formal language, that is like a programming language. Is generated according to a given context-free grammar. The grammar is contains the productions or rules. We have seen that the formal definition of the grammar in the previous video. So grammar contains the non-terminal, terminal, starting symbol and production. From the productions, we are going to generate in the string. Clear? We are going to generate in the string. For this productions, we are going to draw in the derivation tree, or we can say that parse tree or syntax tree. It is a visual representation of a tree-like structure. What it represents? A derivation tree will illustrate the hierarchical breakdown of a string. How the string is going to be generating through or via production rules. Showing the sequence of productions rules applied to transform a grammar start symbol into a final string. Right, we have the set of productions. By substituting those productions to generate a string, it's like a family tree for a sentence where a parent nodes or a grammatical constructs is a non-terminals and a child's or their constituent parts, eventually leading to the actual word or symbol, or we can call it as terminals. Clear? All the parent nodes are represented with the non-terminals, that is variables. All the children are represented with terminals, that is symbols, which generates the word. And we have some key components like root node, internal node, leaf node, and edges. These are the key components for representation of derivation tree. Here, the root node represents the start symbol of a grammar. By considering the start symbol, S will be represented as a root node, the initial point of a derivation. Internal node represents a non-terminal symbol, which are intermediate element in the derivation process and are expanded further using production rules. By substituting the sequence of productions, the internal node will be extended. Leaf node represents the terminal symbol or empty string, that is epsilon, forming the actual string being derived. That is the leaf node, it contains the terminal or epsilon. It gives us the meaningful sentence. Edge indicates the application of production rule, showing how it corresponding productions right hand side replacing a non-terminal. That is, we have the sequence of productions. Each productions derives from left to right, LHS to RHS. We can say that LHS contain the non-terminal. RHS contains the combination of non-terminal and terminal. That will be substituted in the intermediate node or at the root node to generate the string. Clear? Now we will construct by example. Suppose the following production rules of a grammar. That we know that grammar is a 4 tuple V, T, P, and S. That is variable or non-terminal, terminal, starting symbol, and production. Here the starting symbol is S. Here we have the totally one S tends to S plus one production, S tends to S star S is one another production, second production, S tends to X is third production, S tends to Y is a fourth production, S tends to Z is a fifth production. Totally we have the 5 productions. And it is going to be generated in the string is called as X star Y plus Z. That is the string generated with those productions. Right? Let us check how it is going to be generating by substituting the step-by-step process. In the first step, I am going to consider the S tends to S plus S star S or S plus S. So by this production, S will be the root node here. These are the intermediate roots S plus S. From this, S derives S plus S by using the step 1. That is the S tends to S plus S. Next, I am going to considering second production S tends to S star S. At the left side, first variable I am going to considering. That is S tends to S plus S. Right side, first left variable, non-terminal, I am going to considering. In that, I am going to substitute in the S tends to S star S. S tends to S star S. Step 3. By using S tends to X. Y means in the given input string X star Y plus Z is an given input string. We have to generate that. So first we have to get the X. Already we have the star here. So here before the star we have to get the X. So in the step 3, by using S tends to X, at the place of S I am going to substitute in the X here. Here X is the child node. So that is the terminal. Now as per the according to the input we got X star. Next I have to get the Y. So by using X tends to Y in the step 4, I am going to substituting Y here at the place of S. So now I got that X star Y plus. Next I have to get the I have to substitute here at the place of S with S tends to Z production. So in the step 5, by using S tends to Z, I am going to substitute in the Z here. According to the input X star Y plus Z, we got that X star Y plus Z. We generated the string here by substituting the suitable production in the place of root or intermediate nodes. At last, we are going to get the child node. All are the terminals. Clear? This is the child node. All are the leaf nodes, or we can say the leaf node or a child node. All are the terminals. That is a symbol. Clear? Next, what its importance? In the syntax analysis or parsing, the derivation trees are fundamental to parse in a compiler design. We are going to using that parse or syntax in the compiler design, which helping to understand the structure of a program and ensuring that adheres their language as grammar rules. To check the grammar whether the written statement is correct or not, it will be shown in the syntax analysis at the part of compiler design. And understanding of ambiguity, that is for one string we may have the more than 2 solutions. At that time what internally it is going to be happening, it can be seen in the derivation tree, whether it is going to be substituting in the left hand side or the right hand side. Yeah, the grammar are considered as ambiguous if a string can have more than one distinct derivation trees, potentially leading to difficult interpretation of a same code. Derivation tree helps visualizing this ambiguity. And formal language theory, there is a crucial for providing the properties of formal language and the grammar, including demonstrating the power and limitations of a different types of grammars. For that, mostly it is going to be helpful. Right? Next, coming to the types of derivations. we have the two types. One is the leftmost derivation tree and the rightmost derivation tree. In a leftmost derivation, at each step, the left non-terminal in the current string is expanded first using the production rule. That is, by saying that S tends to, in the previous example, S tends to S plus S, we have LHS is S, RHS is S plus S. Clear? So, for in the RHS, we have the left hand side production S plus S. The first S is going to be considered for the leftmost derivation. In that, first we have to expand that S. After that, we will go with the next variable, that is next non-terminal variable, until to substitute the terminal, we have to expand that first production rule. This method is useful in the top-down parsing technique like recursive descendant parser. Next, we have the rightmost derivation, that is S tends to S plus S. S at the right hand side. Right hand side, we have the right side, we have some non-terminal, that is S. First, we have to substitute, or we have to expand that first. In a rightmost derivation, each step, the rightmost non-terminal in the current string is expanded first. The rightmost derivations are commonly used in bottom-up parsing algorithms such as shift reduce parser. It is the concept of compiler design. Let's see by considering the example how we are going to be generating leftmost derivation tree and rightmost derivation tree. Let us consider an example. E tends to E plus E, or E tends to E star E, or ID. It generates the string ID. Input is ID star ID plus ID. We have to generate this string by using leftmost derivative and rightmost derivative. So any one of the production has to be considered first. So I'm going to generate in the leftmost derivation tree first. So first step is I'm going to consider in the step 1 E tends to E plus E. So E will be the root node. Root node derives first E, next plus, next E. Right? In this production, this is the right hand side. This one is the left. This is the right part. So in the left side, first we have to expand this E. That means I have to substitute or expand this E to get up to ID. Right? Now I am going to be expand this left hand side E first. So in the next step 2, the production is E tends to E star E. Already we have the E, we have to expand this. So E tends to E star and E. In the step 3, I am going to substitute in the E tends to ID. ID is a terminal here. So in the part of E left hand side, for this production, this is the left hand side. So here I am going to substitute in the ID. Clear? So I completed this part. Now I am going to expanding the right hand side of the left side. Right now I want to substitute here ID. In the step 4, I'm going to consider the E tends to ID. I'm going to substitute here ID. Now it fulfilled that ID star ID plus. Now I have to substitute ID here in the rightmost part of the non-terminal. So in the step 5, I'm going to consider in the E tends to ID. At the part of E, I'm going to substitute in the ID. So finally, I got the ID star ID plus ID by using the leftmost derivation tree. Clear? Next, same example. Now I'm going to consider constructing the rightmost derivation tree. Right, rightmost derivation tree here. The first I'm going to consider in the E tends to E star E. So E is the root node. The intermediate roots will be the E star E. This is the rightmost non-terminal. In this part, we have to expand first, right? This is the rightmost. So we have to expand the C first. So we have to substitute here by considering the step 2. E tends to E plus E. So already E is there here in the intermediate node. Now it has to expand E plus E. E plus E. Clear? Now again I have to consider the rightmost. This is the rightmost for this tree. Step 3, I am going to consider the E tends to ID. That means here I have to substitute the ID here. So I am going to substitute the ID. From right side I am going to substituting and fulfilling this string. Now I have to expand this E by substituting in the step 4 by substituting E tends to ID. At the place of E I am going to substitute with the terminal, that is ID. At last we have E here. I have to expand this with terminal. In the step 5 E tends to ID. So finally I got the ID star ID plus ID string. So same input is derived with the leftmost and rightmost, right? Same input we got. So we can say that for the same input we got the leftmost and rightmost. Then we will call it as ambiguous. That is, for the single input, for the single string, we are going to be generating two different ways of the derivation trees, leftmost and the rightmost, but we are having the same string here in the two different ways. So that we are saying that it is an ambiguous. If we have only a single solution, then we'll call it as unambiguous grammar. Clear? Ambiguous means for the problem we have the more than two solutions, or we are generating the leftmost and rightmost both for a particular problem. Then we can say it as it is an ambiguous grammar or ambiguity of a grammar. Right? Here we see in that in this today's section we see in that derivation trees, what are their importance, what are the different names, and ambiguous and unambiguous. I hope that you understand the concept of derivation trees. Please share, like, and subscribe. Thank you.